All right, thanks for joining. So this session is about Kubenet. I don't know how many people here have heard or are familiar with Kubenet or are here for the first time. So can I see a show of hands? So that's pretty good, right? So let us introduce ourselves first. So my name is Wim Henderickx. I'm the CTO of the IP division in Nokia, right? And I'm very excited that Ashan is joining me in this talk. So he's from Swisscom. He's doing the product management for a number of things in Swisscom, right? So what we try to do here is, so the goal of this session is to give you more an overview of what Kubenet is about and what we are trying to establish, right? And then we go into the journey that we are through and what we see and how we came about, right? So if you look to the, oops, the other way around. So if you look to the beginning, so what did we start, right? So I'm more in the networking space, right? And what you see is that we have here the world of cloud native and stuff like that. If you look to the networking world, we are far from that, right? Because a lot of the people are talking still physical boxes and stuff like that. And when I looked at automation, I was intrigued by everything that was happening from a Kubernetes point of view. And then I said, okay, we should actually move a step forward, right? And as a result, Kubenet started as an initiative to educate people around cloud native for automation and orchestration, right? Now, what we then saw is that in order to do education without actually having something to train people about, because we can train people about Kubernetes, but actually the use case is not really relevant for those people, we decided to start a number of open source initiatives to actually help the case, to actually show the use case, which is basically focused on networking, but do it in a way that we try to build what I call reusable components that are not only tailored towards networking, but can be actually used in other scenarios, right? And in this talk, we hopefully can clarify what that means, right? But of course, the use case that we are focused in the Kubenet community is focused on networking, but you'll see some of the components that we use are actually very generic and can be used for other use cases, right? And you will see Swisscom, for example, uses it in a let's say, a different environment than actually Kubenet, which is focused on the networking side. To set, I'm always going the wrong direction. Sorry about that. So to set the stage a little bit, so we are here in the cloud native space. What did drive us is basically the Kubernetes API server. So typically, the way I try to explain always Kubernetes, I see it as a project that is tailored towards container orchestration, right? But they also built, and we can debate, so it should have been a project that actually separated the API server for generic automation and orchestration from the use case. But Kubernetes as a system is an entity. In this presentation, we are not so much focused on the container orchestration side, but really on the API machinery that supports the automation and orchestration, right? So that's kind of just to set the stage. And so Ashan will take it from here to, correct, the other way around, I think,
Yeah, thanks. So let's zoom in a little bit on what Wim explained about this Kubernetes API machinery. So,
this is the,
yeah, I'm just going to click through it. Yeah. So let's look into how this how Kubernetes is used on the container orchestration, right? So before I go into detail, who here uses Kubernetes in day-to-day basis? Okay, so I can skim through this slide then. So what's really interesting in the container orchestration space, what Kubernetes has done is they have taken this problem statement on orchestration and they have dissected into smaller components. And on these smaller components, they've also introduced abstraction on all the different components that they have. For an example, in the container orchestration space, there are these objects called deployment, pod services, persistent volume claims, etc. And on top of that, what they've also done was they have this declarative API where you can pass this intent-based request. So what this means is you declare what you want, and the system defines or decide on what to do with it, which is quite nice if you look into like from the consumer as a consumer model. So what we want to do is we want to use this thinking or the framework and apply it to the networking space. Maybe one thing I missed to explain here is these smaller components, what they've also done is they have taken it as like they master one component and one thing at a time. So they don't try to do like many things in this one component. So they really make it like in a consumable, and also this they have this composability within the framework. So for us, I'm going to set the scene for the next 3 slides on what our requirements, or how should we tackle this, right? So obviously at the bottom, like these blocks, the first is the runtime. We need to have some runtime environment to implement or like build the automation on. So in this case, it would be a 5G core running on Kubernetes, or some networking devices running on Kubernetes. And some sort of actuator, like this is where like GitOps can help us, right? So there's tools like Flux, Argo CD, etc. And what's on top is what do we need to input, so the actuator will apply this configuration into the runtime environment. So the question is, this is good enough, but then is it really help, like if you have like the pure GitOps? The answer is no, and so yeah, so we need to dissect this what component into, similar to the previous slide, we also want to look into how do we bring abstraction on many layers. So for an example, if we want to deploy an APN, we define the high-level intent, and then we dissect this into the composable objects, like the IP handling, the VPN, and then also the configuration, etc. And also, you see these 2 arrows, right? So from the top to bottom, we also want to introduce this abstraction, right? And also, we want to map the operational state from bottom to top. So it's like, so if something fails, we want to map exactly where it fails, because you tackle with the high level, like the abstraction. So yeah, so Kubernetes can be used as this framework. And I would like to go through some of the stuff that we like about Kubernetes. First is it has this extendable API. So it supports custom network resources. So we can define CRDs, like if you want to tackle like netconf or Yang. So if you want to do it in a declarative way, you can have these CRDs implemented. Again, it's a declarative API, so you define what you want, and the system takes care of how to do it. It's event-based. So one of the nicest things with Kubernetes is it has this event-based as compared to the Ansible or Terraform. So Ansible or Terraform, it has this workflow model, right? So you define something on top, and then you wait till this workflow is executed. With the event-based, based on the events, these controllers within the Kubernetes, it reacts to this. So it's very dynamic. So for an example, if you have like IP addresses changing on the dynamic way in a live network, all the surrounding things react to this, which is quite nice if you want to have like a dynamic environment. And also the ecosystem. I mean, look at here, like with the KubeCon, we have large community aspect and also a lot of tools around it, so we can leverage these things without reinventing the wheel for the network space. So there's a lot of green things here, but there's also some things that there are some gaps we need to address if you want to bring Kubernetes into the networking space. So yeah, so the first thing is the change management and the reliability and the relationships, right? So with Kubernetes, one of the things that they tackle is we look for the eventual consistency. I think I saw it in one of your slides. There's consistency can be achieved over time, right? But we are working with the networks and the telco-grade applications, so we need to make sure that we have set the right guardrails, etc. So this is something that's not supported natively.
Yeah, so that's one of the things. I think what we see is that if you look to networking and telco, we are part of critical infrastructure, right? One of the feedback that we get from people in the KubeNet community is that, I mean, if you look to Kubernetes core, it's eventual consistency, right? Eventual means when. If you are going to talk to people with critical infrastructure and you say that, it's a no-go for many people. So in other words, one of the things that we want to address in KubeNet is actually having, it's what we sometimes say is, we want to operate networks like we operate, or like planes are flying in the sky, right? We don't want them to be dropped from one to one. So we want to actually build a system that is rock solid, and that if we say that something is committed, it actually works, right? So that's one of the key principles that we want to add in the Kubernetes. Sorry to...
Yep. No, all good, yep. Yeah, the second one is the state awareness. So this goes hand in hand. So Kubernetes itself, by default, it doesn't track the operational state. So when you apply these abstractions of layers, like for an example, like the high-level intent to the low-level, like the device config, we want to see the state mapped from all the way from the bottom to the higher level of the configuration. The third one is also the reproducibility and the rollbacks, right? So if something goes wrong when we have this decentralized approach, we need to be able to roll back and test things quickly. And also this Git integration is not done by default. So it's something added on top, right? So we need to be able to test this candidate configuration in the networks and also have this the version history added. Obviously, once you have the Git on top, you can achieve this, but this is not supported natively. The last part is, yes, the Kubernetes can be used to extend the use cases, but there's a higher level of barrier to enter into this. So for an example, us as network engineers, we use Ansible, Terraform, etc. In our space, we also have Ginger templates hydrating the configuration. But how do we bring such configuration into this space with the use of plugins, etc.? So with that, Wim will discuss on how we tackle this sort of things with Kubenet.
Let's see. Now, at a high level, so Ashan explained a little bit what are the requirements, right? But if you look from what we try to do in Kubenet is basically we build network automation, right? So in other words, first thing that we have to do is like Kubernetes did for container orchestration, you basically you segment the problem into reusable components, right? You build abstractions and do it in such a way that they are vendor agnostic and abstracted away from the implementations, right? So if you look, so this is a very high-level diagram that I'm trying to show. So at the top, we have a network, let's say API, or a CRD, right? That basically says, okay, I want the network. And for us, we don't care whether it's layer 2 or layer 3 and stuff like that, right? We just want a network, okay? The second thing that we did is that we abstracted away the technology that we use to accomplish that network. For example, some people use VXLAN, some people use SRv6, some people use MPLS, right? So at the highest level, at the network level, you don't actually say what type of technology you use. You actually say, I want a network, right? So in other words, the network design, CR, is the one that actually abstracts away the implementation. Also, for example, we have in there, so some people use IPv6 only or use dual stack and stuff like that. So it's all abstracted away from the higher level API in order to make it easy to consume, right? And then what you see in networking is that we typically have lots of topologies, right? So in other words, we need resources like, we need a topology like we need nodes, we need links, we need IP addresses, we need VLANs and stuff like that. So we added native resource capabilities inside of the Kubernetes API system. And so in order to actually assist the automation to accomplish the job, right? And what we do then in Kubenet, we have a set of business logic that renders towards what we call an abstract device configuration. So in other words, if this is deployed on Nokia, Cisco, Juniper, Arista, we don't really care, right? So in other words, it's abstracted away. And then from the moment we know, okay, it's implemented for this specific environment, we render it to the specifics of that implementation, right? So that's kind of what's happening under the hood inside of the thing, and I believe that, okay, so this is for networking, but actually if you look to Kubernetes, they did somehow the same thing, right? So if you look at it, the deployment is very abstract, and then you get more and more specific implementations depending on the implementation that you actually use. So that's basically what we wanted to accomplish, and then we said, okay, in order to do that, which building blocks do we need to accomplish that, right? So then we built a mental model. So this is the mental model, and there is lots of this on the slide. And we try to segment the problem space into multiple components. So the first component that we have is that if you look to network devices these days, YANG is the standard to interface. So it's either Netconf or GNMI, right? It's typically the protocol that we use to interact with the devices. So we said, okay, we need a provider that is actually there to interact, so that maps the Kubernetes API system into a YANG-based system. So the first thing that we did is we built a provider, so that's what SDC is, and Ashan will give you some more color on what that is a capability that maps Kubernetes resources into a YANG-based system, right? So we built that vendor agnostic. So in other words, whether you use it on our gear or other gear, or we don't care. So, and we have proof today that actually it was originally built for network equipment. It works with optics, it works with 5G, it works with very different use cases, so we built that in a vendor-agnostic way. The second layer that we built, which I abstracted into actual Desire and Desire Prime, is basically the change control system, right? So in other words, what Ashan tried to explain at the beginning is like, we have a runtime, which is what I call the network. We then need to define what are the configuration artifacts that we need to apply to that runtime, right? And that's where GitOps is then used to actually actuate it. So if I talk here about the actuator, you can refer to it as GitOps. Now, we built some extensions in that system to make it rock solid. So in other words, we build in transactionality to ensure that once you say, I'm going to apply to the network, your commit is not going to merge to main unless it actually worked, right? So that is one of the things that we did differently. So we use GitOps principles as the actuator, but we wanted to ensure that once we actually apply a certain configuration onto the network, it actually works, and only when you know it works, it gets committed to the main branch, right? So that's one of the changes that we did in order to get that, what I call, to run on a critical infrastructure. Then, from the moment you have that change control layer, the challenge is the tooling that you need. So if you look to the previous slide, right, so to come from that abstract model towards that device-specific configuration that is vendor-specific, you need quite a bunch of logic to figure it out, right? So we need, and so we try to work on a component that makes that way more flexible. So what we saw today in the environment with the tooling that is out there, you have a lot of tools that basically render or a template and can parameterize a parameter. But in order to do that at network scale with all the relationships, we felt that there is some, let's say, challenges in order to accomplish that. So long story short, if you look to Kubenet, we have actually 3 projects that you could say are then supporting Kubenet initiatives. One is SDC. Second is KUID, which is basically a resource identifier. And then we have Choreography, which is basically an orchestration layer. We'll go in a little bit of detail on each of them in the next couple of minutes. But Ashan will start with the SDC side.
Yeah, so I guess everyone has used netconf in here, because everyone's from the telco side, I believe. And one of the challenges to bring the netconf side into the in-band Kubernetes is how do we tackle this proprietary telco protocols like netconf, how do we do it in a declarative way? So that's where this tool comes in. I think it's very cool that it's open source and also everyone can use it in a vendor agnostic way. The SDC stands for Schema Driven Configuration. You can check out this link if you want to look into more detail. So one of the use cases in Swisscom is we use this tool to configure the 5G core. So we achieved it, we tackled this, the UPF as the first one, and then now moving to the control plane nodes and etc. It also supports transactions, and it supports both GNMI and netconf protocols. Feel free to check it out. One of the nicest things with this framework that we mentioned before, it's also pluggable. So how we use SDC tool in our environment is we use SDC with the GitOps tooling without the other components. It's also linked to the IP management, the tool, or the operator that we use, Netbox operator, where Joel and Leah will explain in the upcoming presentations. So that's how we use this SDC tool as a use case at Swisscom.
Thank you. Yep. The next, so the other project is what we call KUID, so it stands for Kubernetes Identifiers, right? So one of the things that we saw early on is that we needed to render the config in a network device, we need topology, we need inventory type of objects, which were not natively there in Kubernetes, plus we needed an IP address management, VLAN, AS numbers, and stuff like that. So KUID is basically a project that maps native Kubernetes identifiers inside of the Kubernetes ecosystem that can be leveraged for any use cases. So we have people today that use it, for example, for private 5G deployments. We have people that use it in the networking space. So it's actually very generic things. And what you'll see is that the Swisscom people, they don't use KUID, for example, because they have built a netbox operator as a way to actually do a similar thing or use it in a similar way. And so we wanted to build this project in such a way that we can be pluggable and that we can reuse the components no matter how it sees fits for your environment, right? The third component, which is actually, I'm pretty excited about, and it's very early days, which is called choreography. So I'll typically try to explain this as choreo. So one of the things that we saw is that if you look so what we want to accomplish is basically, at some points we want to go from an abstract to a device, so something that is actually applied to the runtime, right? And the tooling that we have to accomplish to come from an abstract thing towards that specific entity is, so there are tools, but if you want to have rather complex or more complex use cases, you see that they fall short and it becomes very complicated, right? So what is Choreo as a nutshell? It's basically that orchestration layer, and what it's doing, it tries to tackle the issues that we see, that Ashan was mentioning in the Kubernetes ecosystem. So first of all, version controlled is a first-class citizen, right? We added relationships, because what we see in, for sure in telco, but for sure in networking, is that everything is connected. And so when we started to build Kubenet, we see that we actually had to build lots of parameters in all of the APIs to build relationships. So in other words, there is no graphing in the base ecosystem, so we added that as a first-class citizen. The third thing that we did is ease of use, right? So I always, when I started this project, I was saying our competition is Ansible and Terraform, right? Because how many people used it, right? But what they lack is they lack the active reconciliation loop, right? So in other words, they don't get feedback, they act and stuff like that. So that's not in those tools. But what they do very well is ease of use, right? And they also don't couple the state with the configuration, right? So we want to tackle this complete environment using this framework. So what we try to address with Choreo is basically, you could say it's an orchestration tool. It's agnostic towards the use case, right? But what is clear, what is important is that some of these, let's say, issues that Ashan was mentioning are actually tackled in that ecosystem. It's fairly young at the moment, right? So it's very early stages, but I believe it has lots of promises to get to the next stage, focusing on the simplifications, as well as doing simple things, solving complex use cases in a simple way. And I think if we can live up to that promise, that is basically what we are aiming for here. Right? Now, there is no slide without AI. So if you look to my mental model that we started to build from the beginning, right, you see that if you look to the model, we had reconcilers at the top, right? But what I started to also experiment in Kubenet is build the agentic AI or agentic agents into the framework. What is actually interesting, if you look to the system, it's actually very pluggable, because if you look to the knowledge base, so if you look to the slide and you compare it with the previous one, what we actually do is we add the knowledge base into the system, and then you have agents that work in an agentic fashion, and you have reconcilers that work in the traditional fashion, and we can actually make them work together in harmony, right? So there is lots of promises. We did a bunch of prototyping recently, so it's fairly early days, but the idea is that Choreo as a tool will support both agentic agents as well as traditional, let's say, automation using classical programmatic interfaces.
Yeah, I think that's, we are coming to the end of the presentation. So we've got some related talks and resources if you want to look into it a bit further. The first one is Wim has done an overview of the SDC tool with the Yang management. Also, we've done a couple of talks on KubeCon last year. One of them is highlighted here, the journey with at Swisscom on the GitOps and the KRM approach. And also there's a collected list of the communities out there who tries to tackle the same thing. So it's also, we are not alone in this space, and we should find more synergies, etc. Yeah, I think we gave you some appetite to try this out. So if you want to look into it further, these are the links. We've got a Discord channel, the documentation on all the tools, etc., and what's Kubernetes tackling. It's in GitHub, and also there are a lot of training material in YouTube. So it's a very friendly space. So if you want to check it out, feel free to contribute to the code, give feedback, try out these things on the use cases, and be involved. Yeah.
And maybe one more thing is that today it's not yet in a foundation, right? So one of the things that we can say is that we will bring this to one of the foundations that is out there to support the system, such that we have, let's say, the full community support. So the idea is to make this community grow and actually help us for sure in the telco space, right? And I don't know whether we have time for questions, but I'm happy to take the question.